this next slide, and this is the part you have to press. Like this.
Perfect. I think we are set. So, your turn.
Good morning. I'm happy to be here and to have a chance to present one of our projects at Fernfachhochschule Schweiz, or in English, Swiss Distance University of Applied Sciences. So this project is InnoSuisse project. It is done in collaboration with a startup called Skills Finder and our research institute, Laboratory for Web Science at FFHS. So goal of this platform is to facilitate and automate recruiting process. And we want to automate skills extraction from CVs, and then to validate these skills with the help of references and certificates. Okay, so our platform consists of 3 components. So we, in the platform, the documents are coming in PDF format. Then first it's necessary to convert PDF to text. Then for skills extraction, we use named entity recognition. And from named entity recognition, besides skills, we also get embedding vectors of these skills. And these are used for to compare skills found in CVs with the skills found in references and certificates. And after the final output are skills with validation flag. Next, I will describe in more details each of these components. So first, PDF to text. Well, when I started to work on the project, I thought that this is kind of solved problem that it's just to apply one of the existing library, but it appeared not to be so. So why? So CVs, they have a very complex layout with diverse so they can be like in one column, 2 columns, or even 3 columns, or some combination of these. And so I've tried many of PDF parsers, and none of them could do the job for all these possible layouts. So because of that, we decided to train a CV layout model that will help us with PDF parsing. And since in CVs, these are native PDF documents, so we combined PDF parser with our trained CV layout model. And on the other hand, references and certificates, they have a simpler layout, mainly 1 column. And there we don't use any layout model, but they are scanned images. And actually, because we are, we don't have much resources, and we wanted to use only open source tools. And it was not easy to find open source OCR that works well for our scanned documents. So I've tried several. And at the end, the best was document text recognition, OCR. So this is also one point to consider. So, yes. And so what does this CV layout model mean? So for this, we use a unified toolkit for deep learning based for document image processing. And this is called Deep Layout Parser. And layout model is basically object detection model made with Datacron 2. And so what we here want to achieve is to divide CV into some hierarchical text blocks that would capture kind of reading order, and so that the columns are not mixed. And so we have, we define blocks of two hierarchical levels. And so with level 1, we designate these main blocks in CVs like working experience, education, and so on. And we have also one more category that is title of the text block level 1. And this will help us actually with, as we will see later, with named entity recognition. Okay, so with a benefit of this CV layout model is improved PDF parsing, so that we don't get mixed columns, but also input to our named entity recognition is limited to maximum number of sub-tokens. So we need to split our CV so into some text chunks of fixed length. And so this layout model will also help us to do this in a some semantically logical manner, because in CVs we really don't have sentences that we could just split the text. And also we will in our performance, we see that this helps with performance of our named entity recognition. Okay, so that was about converting PDF to text. Next is how we do it, skills extraction through named entity recognition. So for this, we use contextual BERT language model, and we combine it with fully connected layer. After softmax, we get extracted skills. And so, as I said before, we have here limited input. So in our case, it was 256 tokens. And so we use for this CV layout model to logically divide CV into, and to give input to BERT model. Okay, so as I said before, beside the skills, we also get embedding vectors of each skill in order to do skills validation. And embedding vectors are simply output vectors from the BERT model, as shown here. And okay, next is about skills validation. So we, as I say, first we extract skills and its embedding vectors from a CV. We also do this with references and certificates. And then we compare these embedding vectors by using cosine similarity to get whether these skills that are found in CVs, whether they are also mentioned somewhere in references or certificates. And we get skills with, then as output, we get also validation flag. And skills are not only one word. It can be also a phrase, a set of words. So in the case when we have several, that the skill is several words, like for example, I like to communicate with people, then we are using with obtained embedding vectors also mean pool operation. It's basically mean of the embedding, mean value of the embedding vectors, and then we get one vector that represents this skill phrase. Okay, so for our system performance, data set that we use are collected by the startup skills finder. And in total, we have about 200 pages of CVs, 100 references, and also 200 certificates. And all these are labeled with this company. And we have, beside skills, we also labeled several other categories like name, education, employment, and so on. But our focus in this work was extraction of skills. And we, as natural and machine learning, we split data set into train test. And accuracy is for skills extraction, about 80%. And we are mostly happy with this, but we hope with more data, this could improve even further. And the platform will start to work soon. So after we obtained more data, then it will be, the models will be retrained again. And actually, it was very difficult to get CVs from users. So because of that, we don't have very huge data set. And for skills validation, well, it's about 65%. And so for this, we are not still yet where we would like to be. And we have also some more ideas how we can improve this. Like for example, for now, we trained the whole model, both BERT and fully connected layer. And for example, maybe with just freezing BERT, this would help with maybe not moving these vectors, the whole vectors into one space. And for the other, we could also fine-tune BERT on our CV's data and references and certificates. So, yes. And so to summarize, so our platform consists of a converter of PDF to text, in which we use for CVs combination of our trained CV layout model and PDF parser, and for references and certificates, which are scanned document images, we use document text recognition, OCR. For skills extraction, BERT-NER model is used, where we use pre-trained BERT model with fully connected layer. This gives us named entities or skills. And plus, we obtain from BERT model outputs embedding vectors, which we then use to make skills validations. That means to compare skills that we found in CVs with skills that we found in references and certificates. And if skills consists of set of words, then we use min pooling operation to obtain the one embedding vector for this phrase. And for using a similarity matrix, we use cosine similarity, which also we consider maybe combining also with other type of distances like Euclidean and so on. Okay, so I thank you for your attention.
Thank you, Natasa. Are there any questions from the audience regarding the OCR steps, the applying the name entity recognition or something further? Yes.
Hi, thank you for the talk. I have a question. Since you don't have a lot of data, have you tried maybe some data augmentation or generating maybe synthetic data to have a starting point?
Sorry, I didn't understand the question.
Have you tried data augmentation to generate maybe some CV for a starting point?
For CV's generation, no, that was not the part of the work.
Okay.
But yes, this could possibly improve results. Yes.
Okay, thanks.
I think there's another one. If you can just give it further.
Hi, Natasa. Thank you for the interesting talk. I have a question about the annotations you have to do for the labels. Which tool did you use, or you use the engine from Layout Parser?
Well, we didn't use any tools. We simply, because we needed to parse our CVs. So we first parsed CVs into text, actually in one column text, and then simply manually we did annotations. Mm-hmm. Because these tools also use above engine for PDF parser.
Right. And do you think it's intensive or?
Yes.
Could it be better?
This would be probably easier if I would actually my PDF parser integrate into these kind of tools. But yes, it was also time consuming.
Yeah, we can talk offline. So at ETH, we've developed a tool that comes with the annotation engine, and you can drag and drop and also define your own label set with the PDF miner incorporated. Another question is we've evaluated layout parser on tabular data, and sometimes before formulated CVs with tables, with table models. And do you find layout parser actually performs well on the tabular data on the CVs, or it's manageable?
You mean for tabular CVs?
Mm-hmm.
Because I mean, I had some examples in a CV, but because I use this CV layout model, it will somehow manage to get some text blocks, but it will not work if there are, to say, a lot of columns.
Exactly.
But it will, my original idea was also to have a hierarchy until 3, but then it was too intensive, so I decided to have 2 because we don't have so many such examples of CVs.
Mm-hmm. Mm-hmm. Exactly. So on the same line, our tool does the hierarchical mapping of the segments within the table, so which might be helpful to you.
Yes.
Yeah.
Yes.
We can talk offline. Thank you very much.
Hi, thank you for your talk. Am I correct in understanding that the numbers that you are reporting here is through the entire pipeline? So if so, do the numbers basically, or the errors basically aggregate from the Burton NER model to the face similarity model? And if so, have you tried like training the models individually instead of going through the pipeline?
Well, okay, so for this, the results are from text until the end, but not for OCR. You know, once we get text, then we annotate this, and then, but for OCR and CV layout model, we don't have really numbers, but through our, say, manual work, we noticed that we don't miss, that we maybe just in rare cases, we missed some skills. So, but yes, this is the part that still needs to be evaluated.
So you mean your PDF to text model is pretty perfect, so to say, but the other ones are still can be improved?
Well, not to say perfect, but almost to say that it works well for our purpose.
Okay, thank you.
Thank you. Is there any further questions? I would have a last one, which is basic. I was wondering if you guys have used any or applied any ontologies, so skill ontologies, which you would have run over this text, or is that something maybe you're envisioning for the future work?
Well, no,
Okay.
we didn't apply this.
Okay, good. I would say thank you very much, Natasa. I would invite Kevin, if he's already here, to come. You have a little bit time so that maybe other colleagues can join from the other tracks. So yeah, I think Davide will make some magic here. So we are moving from so we first were at the corporate, went to startup, and now we're moving back again to a corporate environment. But